in analysis of variance, or ANOVA as it is popularly abbreviated, we are to compare the null hypothesis of no significant difference between the averages coming out of more than two populations. Obviously, our study is based on sample collected from these populations, and we are to compare the null hypothesis that the average of the different populations are not differing significantly, to be tested against the alternative hypothesis that at least one of the averages differ significantly. In one-way analysis of variance, as the name indicates, there is only one source of variation in which the populations are coming from, or populations are divided. However, in two-way ANOVA, we have two sources of variation. So in two-way ANOVA, basically, we'll compare the means for more than two populations, but we have two sources of variation. So accordingly, we have two null hypotheses. One is related to the source 1 or factor 1, and another related to coming out of factor 2. And in both the cases, there are multiple number of populations whose average are to be compared. Today we will see how the analysis of variance, both one-way and two-way, can be performed in R package. Now friends, this is the data set which we want to analyze, or for which we want to do one-way ANOVA. So 4 different companies, we want to compare their average life of the bulbs, and then we will be using ANOVA there, as you know, one-way ANOVA. But here we don't take the data in this way to R. Rather, we need to arrange it in a special way, as you can see here. So company 1 has 7 observations. So what I do is that we prepare it like this, that we write company 1 7 times, and the corresponding value like 1600, 1610, like this up to 1800 we write under company by the side of company 1. Next we have 5 values. These 5 values will be company 2 coming 5 times, and the corresponding values in this way. Similarly, for company 3 and company 4, we arrange the data in this way, and then we can call it in R. This is called as the flattening of tabular data. So flattening of tabular data is almost required for all ANOVA computations in most softwares. Whether it is SPSS, R or Python, we need to flatten the data when we want to do ANOVA. So this has been done, and we have saved it as a CSV file, preferably in my documents with the name ANOVA one way, and we'll call it in R console in that way. So over to R and to see how this computation is done. ANOVA, one-way ANOVA is done in R. So friends, once we type in the data in Excel and save it in documents or my documents of our computer, we call it with the read CSV command. This is the file name, as you can see, ANOVA one way. Header equal to true, that means each row name consists of the name of the variable, and we store this data set in DF. DF means data frame. We just give it a name. You can give some other name as well. Then we write the attach TF command, which actually takes the observations under the name of different variables. And then we want to see what our data or how our data looks like, and this will actually give you first few rows of your data set. So your data set, you see, these are the serial number. Your first variable is life, and which has the lifetime of the bulbs, and then second variable name is company, which has the different companies. So we have only 6 rows been shown with the head command, or there are several other companies, as we have seen earlier, coming one after another. And then this is the main ANOVA command. This AOV, this is doing the analysis of variance with life of the bulb as the dependent variable and classified by the different companies. So different companies will be in comparison in times of their life. So this is the ANOVA 1. Here we actually store the result of AOP. That is whatever results come out of ANOVA. Now if we want to see the result of ANOVA, we use the summary command. And summary, and this ANOVA 1, this is just name of the variable where we store the results.
You may give some other name as per your wish. But obviously AOV you cannot change. That is the ANOVA command in R. And then we use the summary command, and as soon as we press the summary command, we get the analysis of variance, one-way analysis of variance table. So these are the sources of variation. Company is one source of variation, another one is unexplained, and that is the residuals. Now this is the corresponding F value of ANOVA, and this is the corresponding P value. So P value will actually help us to take a decision whether all the companies have uniform life of their bulbs. That means whether the life of the bulbs are uniform across the different companies. And here we see the P value here is less than 0.05, it's 0.0242, which is less than 0.05. This implies that the lifetime of the bulbs of different companies vary significantly. Now, if that is our null hypothesis of the test, that all of them are having similar lifetime of the different bulbs of the different companies, gets rejected. If our null hypothesis is accepted, that if they are same, then our analysis stops here. But since it is showing some difference, then we go forward and we want to see that who is different. Company 1 is different from company 2, 3 and 4, or company 1 and 2 is different from 3 and 4. What is the combination, or who exactly is different, or which of the companies are actually producing bulbs with a difference. So once we find that there is significant difference between the groups through our ANOVA, next we perform the TUK test, and the command for that in R is TUK HSD, and ANOVA 1, if you remember, that is the name of the variable where we have stored the result of ANOVA. So we call it, and then as soon as we press enter, we get this type of output, and in this output, as you can see, it gives pairwise comparison of the different companies in terms of their lifetime. First one, as you see, the difference is negative. It means that C1 has more lifetime. Bulbs of company 1 has more lifetime than the bulbs of company 2. And so that is the case wherever you see negative. The second one is having more lifetime than the first company which appears first. And if you look at this adjusted P value, this is the P value which tells us about the significant difference between the companies. And none of the companies are significantly different from each other when compared in pairs. Only the difference lies in the last company. If you look at the P value, you find that the P value is 0.01, which is less than 0.05, that is 5% level of significance. So the lifetime of the bulbs of company 3 and company 4 differ significantly from each other. So that is the takeaway from this particular TUK test. Now let us draw the conclusion of the entire ANOVA exercise. We write that one-way ANOVA was performed to compare the average lifetime in hours of electric bulbs produced by 4 different companies, that is C1, C2, C3 and C4. That is, here we write the purpose for which we have performed the ANOVA. The model is significant with a P value 0.02, indicating that the average lifetime of bulbs manufactured by at least one of the companies differ significantly. That is the result of the ANOVA which we got, where we understood that there is at least one company whose value is differing significantly from others, at least one, maybe more. And then accordingly we performed the TUK test, and when we performed the TUK test, we found that the lifetime of bulbs manufactured by company 4 and company 3 differ significantly with a P value of less than 0.05, that is 0.018. So this is how we conclude the outcome of the ANOVA exercise that we have done. So this is how we perform a complete exercise on one-way ANOVA. Next we step forward to see how we can perform two-way ANOVA in R. Now let us look at two-way ANOVA. In two-way ANOVA, there are 2 sources of variations, and we are to compare the average across the different groups when there are 2 sources of variation. And so if there are P populations for factor A, then we have P means, that is mu1, mu2, dot up to mu P. And say in the another factor there are Q populations which has means alpha 1, alpha 2, dot, 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 alpha q. Now, your purpose is to test the null hypothesis. Here we have two null hypotheses to be tested, and we have one null hypothesis concerning the first factor, that is factor A, and we have a second set of null hypothesis which is also to be tested based on another set of factors alpha 1, alpha 2, alpha q. And we have the tabular representation like this. And let us understand it better with the help of an example. So here a particular researcher is there who has installed different types of traps for trapping wasp. He wants to do some research in wasp, and for that he had placed traps at different level from the ground. Some of the traps he have placed in the ground level, some in the lower level of the tree, some in the middle of the tree, and some in the top of the tree. So he has placed the traps at different levels. Also, he has given different types of materials in the trap. That means he is using either sand or sugar or chemical. And now, so here you see he has done a repetition also, which was not there in case of one way. It is sand. He is applying sand in one trap at the top of the tree. One trap he is putting sand and attached it to the middle of the tree. Sand he has attached to a trap which is placed at the lower level of the tree, and another trap is there which is at a ground level and which has sand in it. So like this sand, sugar, chemical, these are being repeated, or you may tell it is replicated. So accordingly we have a table like this. Now here we want to perform the analysis of variance in order to find out whether there is a significant difference on the number of wasps that is caught when they are put at different levels, that is top, middle, ground, lower and ground, or whether there is a significant difference between the number of wasps caught on an average when different materials are used like sand, sugar or chemical, irrespective of the level at which they are placed. So this has given rise to two null hypotheses which we will be testing. To explain it clearly, I take an help of an animation. So this is the wasp which I want to catch, or the researcher wants to catch, and these are the traps. So he is attaching trap at the top, at the middle level, at the lower level of tree, and at the ground. So these wasps, they are actually flying, and they are coming from different places, and they are moving, and these they get attached to some of the traps. You see one wasp is at the top, one is at the middle, one is at the lower level, two are at the lower level, got stuck in this trap, and one of them have got stuck in the trap that is at the ground level. So this is what he wanted to do, and he has repeated this. Maybe in this tree he is using sand in all and the traps. In some other tree he is using 4 traps at 4 different levels, but here there he is using sugar, and another tree is using 4 traps at the same different levels, but there he is using, researcher is using some type of chemical. So that has given rise to the data that we saw earlier in a tabular form. Now these are the null hypotheses. One null hypothesis is at which level we want to compare between the levels like top, lower, middle and ground. And the other test is to check out what is the material used, whether some material like sand, sugar and chemical are all equal in terms of the number of wasps that are caught, or they are different. So this is the two null hypotheses which are tested. So this is the table. First, this is our data table which we have. First we flatten it as we have done earlier and write down because here is the location. Here location, it will come the top, middle, lower and ground, and the other one is the material. And here I will write the data, number of wasps that is caught. So first one you see, it is a top level, sand is used and 28 wasps are caught. So let me fill up this, top, sand and 20. Second one is you see middle level, sand is used and 39, also top, this one is having top, this 35. This is top level, sugar is used and 35. Top level, sugar is used in 35. So this is how we actually flatten the tabular form of the data. Ultimately the table looks like this. If you can see, there are 12 observations in all, and this is what happens when they are flattened. So this we actually write it in a Excel file. We save it as a CSV file because R is more comfortable in working with CSV file. So we save it as a CSV file, preferably in my documents or documents of the computer. And then we go to the R console and write the read CSV command, which takes out the data from my documents and saves it in a variable named df. It's a data frame. You may give some other name, you may give data, you may give d1, so on and so forth. But this command, this side you cannot change. Now we attach df command we use. With the help of the attach df command, we actually associate the variables to the different data. So we do this attach df command. Location, these values will be stored under location. These values will be stored under material. These values will be stored under WASP after the attach df command. Prior to that, it is a total data set, not identified as different variables. So that is the purpose of attach df command. Once we have taken up the data, then we use the ultimate command for doing ANOVA, AOP, as we have done in case of one-way analysis of variance, and then WASP, because that is the name of the dependent variable number of WASP caught. Here there are two sources of variation. One is location and one is material, and that is the variable name by which they are known. So we are calling them by their variable name, and the entire result of the analysis of variance is stored in ANOVA 2. This is the name of the variable. Then we give the summary ANOVA 2 command and we get this table. Now once we get this table, we find that corresponding to location, the p-value is less than 0.05. That means there is a significant difference on the average number of wasp caught based on location. But if we look at the material used, this p-value is not less than 0.05. Rather, it is more than 0.05. It indicates that the null hypothesis related to materials is accepted. That means whatever material you use, the average number of wasps caught by the trap will not vary significantly. Rather, they are insignificantly different. But the difference is significant in terms of location. That means location matters, material does not. But I may be interested to see that which location or which locations actually are significantly different from others. So, like the previous one, here we also perform the TUK test. And so we call ANOVA 2, this is where the result is saved, and with which command we actually call the particular factor on which we want to make the comparison. So we don't want to make the comparison on material, rather we want to make the comparison on location, and that is the TUK test. And when we do the TUK test, we get the pairwise comparison of this. Now this is look at the p-values to understand which pair shows a significant difference. Lower and ground value is less than 0.05, indicating there is a significant difference. Middle and ground less than 0.05, this is also significant. Top and ground is less than 0.05, that is significant. That means wherever ground is involved, the difference is significant. And as you can see, here all the differences are positive, indicates that ground has minimum number of catch compared to lower, compared to middle, compared to top, and in all the cases the difference is significant. The difference is not significant between lower and middle, top and lower, and top and middle. So obviously ground should be avoided if you want to catch more number of wasps, because ground is significantly lower than all others. So this is what we understand from this test. Now let us go for the interpretation. We first tell what we have done here. Two-way ANOVA was performed with number of wasps caught for two different classifications or factors, that is location of the trap and material used. However, out of the two factors, only location is found to be significant, but material is not. We have also quoted the p-values correspondingly. Accordingly, we perform the TUK test, which is also called as the post hoc test, for arranging in order to identify which location pairs differ significantly. And then we find that lower and ground, middle and ground, top and ground differ significantly, where other pairs are not. So this is a complete two-way analysis of variance, and this is how we need to interpret our results. We will also see in due course of time what happens or how we perform the analysis of variance in two-way with multiple number of observations per cell. But till then, let us put a stop. Thanks for watching this video. I would once again make an appeal to all of you to kindly subscribe to our channel and share it, the information of the channel, to your friends, students and colleagues. Thanks for watching.